Hello everyone, it's July 14th. Alright, first things first, max area of island. You're given n by n binary matrix. An island is a group of ones connected four directionally, you may assume. All four edges of the grid are surrounded by water. The area of the island is the number of cells with a value of 1 in the island. Return the maximum area of an island in grid. If there's no island, return 0. And if it's four directionally, then that's 1. Okay. So I remember this one. I think, if I'm not mistaken, we do DFS, right? We do DFS when we go here, we go four direction, and then when we hit someone at 1, then we go four directions. If it's another 1, then we yeah, so we when we hit 1, and then we start counting, right? So basically, when we hit 1, we shall be able to count everything. So when we hit 1, and we go up, right? We carry its current area. Now when it says 0, or if it has been visited before, then if it's visited before, we don't visit it. If it hasn't been visited before, we visit it. But if it's a 0, then it's like if it's 0, then we will set the area to 0, right? If it's not, then area plus 1, and then nothing, and then we will return. What do we return? Yeah, so we go here, so we go this, and then return. I need to know the area that's connected to this one, right? So for each one, I want the return is the area connects to the rest. Or you can say when we get out. Now that requires no. So wherever we hit the island for the first time, right, that's when we're gonna return. So we'll go four directions, so we try to get the maximum area in there without hitting again, right? So they will return what's that, and if this one has traversed the rest, then these will be visited, so I don't have to visit again. So yeah, so basically for each one, I will return, and then I can call, right? When we return, I can call the biggest, and if I'm currently a 0, then I don't have to call, right? So only if I'm currently a 1, then I need to do the comparison. I don't know if I'm the first one hitting. Okay, I think this one shall work. I don't need it to be so big. Get it smaller. Okay, so DFS, we have I, J, and actually nothing. I'll return an int, okay? And then we have mn equals line grid. Could grid be 0? Nope. Perfect. Line grid 0. And self.res. We want the largest, so we start with 0, right? And then we say if current is 0, because we have to go to 0, right? If current is 0, we just go for directions. We don't do anything. We return 0, right? So, well, we always go for directions. Yeah, we always go for that. So we should just say for di dj in remember 1. We go I 1 0, right? 1 1 1 1. There's no 1 1. 1 0 0 1 minus 1 0 and 0 minus 1. Nij equals I plus di j plus dj. If we have forgot to use the global visited equals a set. If 0 smaller equal to ni smaller to m and 0 smaller equal to nj smaller to n and ni and j not in visited, I'm gonna visited dot add ni and j and then dfs ni and j, and this one shall return an area, right, which is connected to from ni and j. We find the largest, right, and then for me, well, it has to be. Oh yeah, I can do that. Only if the largest that this one connects to, and the largest, hold on, the largest this one connects to, it shall be area, right? I should say area equal to 0. We shall say area plus equal to this. Then we go it again, then we go it again, then we go it again, right? And once we're done, to go 4 directions, I have an area. Then we say if not grid ij, right? Then I shall return 0 because it doesn't really matter. I don't have an area. Else, I shall say self dot rest shall be maximum. Else area plus equal 1, which is the one I'm currently at. That shall be the maximum of self dot rest and area. Then we shall return area. And then we can run dfs 0 to 0, and then we return self dot rest. Okay, let's see. Look at the input. Extremes. Oopsie doozy. And not correct. This is 4 directions, right? Yeah, and then for each one I say area 0, and then we go 4 directions. Doesn't really matter. Just 4 directions what I want to know is, and these all return 0. This also returns 0, so that's 0. So this is 1. And then we go, and this will return 0, so this is only 1. But if it's here, this shall return, I was expecting this shall return 1. Well, visited, I actually shall set 0, 0 here. Hit 1. What should we do? Well, we can print ij an area and take a look. Didn't even traverse the entire thing. First print is 4. I is 2, 3, 4. 4, 1, area is 1. 3, 1, area is 2. 2, 1, area is 3. Next one is 0, 2. Is 1. Wait, what happened to this? I thought I'm gonna go through all of it. I didn't. That's barely going through some. I don't know what's wrong. This traverse 4 directions, right? And then we have this, so we don't go back again. Yes, strange. You know what? Let me see the traversal. Yeah, looks like we traversed everything, but so we go 0, 0, and 1, 0, 2, 0, all the way down to 7, 7, 0, and then we go 7, 1, 7, 2, right, all the way, and then 7, 11, 7, 12, then we go 6, 5, 4, 3, 2, 1, and then we go back, right? So 0, 12, and then that shouldn't matter. Oh, like if I'm here, right? I call this, and I need a return from this, and then This one will call here, we need to return from this. This one call, and then this one will give it a 0. So this one shall return 1. And I'm here, I call this, and then I will call this. But this has been visited before, so I never called this. Ah, I see. I never called this. So now we need to visit again? That doesn't seem right. You know what? I think I shall traverse it just like this. And every time we hit something, then we go 4 directions. Right? We go 4 directions, but when we hit a 0, we stop. Yeah, so it's slightly different than this. So what I'm saying is, when we hit something, then we go 4 directions. And then if it's 0, we don't. So we shall do like this. Alright, if and not invisited, and we have to go grid ing and grid ing. Then visit, then I visit it. Right? And then when we're done, I know when I visit this one must be 1. So the area when I visit myself, it must be 1. And once we're done, I'll try this. And I will return the area. But I don't have to compare here. I can just return the area. And we set visited equal to a set. And then I would say for I in range m, for j in range n, right? And then say if grid ij visited.add ij, because I'm visiting it, we call dfs ij. And this one shall give us the area. And we just say self.res shall equal to maximum self.res and this. Right? If not, we just keep going. And we will have it. Try this one. This one's right. There we go. So it's the same idea, right? It just every time you hit, then we will traverse the entire thing. Okay. Apparently we have a faster approach. Oh, actually it's not. Okay, let's see what type of approach I had last time. Is this time? Yeah, I'm losing here. This is 1 year. Oh wow. Convert to -1. Ah, I see. Look at how simple this one is. We set to -1 instead of using a visited, and then we just plus the full thing. Yeah, that's the same. And then we pick the maximum. Wow, I like the implementation. I'm gonna re-implement this way. But it's the same idea, right? We have 728 test cases. 728 test cases. This is today. $6.95. Only DFS when we hit an island. Better implementation. These don't change. Yeah, set to -1 is a smart move. And then .dfs I and j return int. Say if grid ij smaller or equal to 0, or I is smaller than 0, or I larger equal to m, or j is smaller than 0, or j is larger equal to n. Any of these situations happen, return 0. Otherwise, grid ij, I'm visiting it, so I set it to -1, and then I'm going to return 1 plus dfs I j plus 1, I plus 1j, I minus 1j, I j minus 1. I'm going to return maximum for I, range m, j in range n, dfs ij. Wow, so good. But it's wrong. Oh, that should be the last. There we go. Yeah, I like to just do it before, but should be doing it afterwards. And also, set it to -1 is a smart way. Oh. But without the overhead of using a set. Yeah, we have this set, and then we have this comparison. Yeah, they all contribute. This is fine. I just decide which one to go. But we have like, we loop through. Yeah, that's fine. And we can do this. And basically, we just need to, instead of doing that, we should return 0. Yeah, that makes things easier. Okay, so that's that. It's done with it. Let's try this one. Percentage of a letter in string. Of character S in S that equal letter rounded down to the nearest whole integer. So I have a letter, let's say counter, right? Counter S letter divided by len S. That's interesting. Wait, the counter, what's count? It doesn't do it that way? You're welcome. Oh, it does. Yeah. Oh, ha! Stupid. Ah, man. Okay, yeah, we have to go times 100. It's a percentage, man. Percentage. Yeah. There you go. It should be right. Yeah. Okay, we can do one more. Yeah, let's do one more. Oh, this next one. Perfect. Maximum bags with full capacity of rocks. These questions have interesting titles. You have n bags numbered from 0 to n minus 1. You're given two 0-indexed integer arrays, capacity and rocks. An ith bag can hold a maximum capacity rocks and currently contains rocks I rocks. You're also given integer additional rock. The number of additional rocks you can place in any of the bags. Return the maximum number of bags that could have full capacity after placing the additional rocks in some bags. The maximum number of bags. So capacity is 2, 3, 4, 5. So I can have this, I put this and this. So I have 3, have additional. But 1 rock and back. Or after number of maximum that could have full capacity. Hold on. If we go 2, 3, 4. So, but this one doesn't count. Bags 0, 1, and 2 have full capacity. Oh, no. We have additional rocks. We have 2 rocks. So we put 1 rock here and 1 rock here. Okay, because it's only possible to have more. Not possible to have no more then. Yeah, we can put 1 here, that's 2, and a 1 here, with 2, 4, 5. That's also 3 capacity. Okay, so place 8 rocks. Oh, this is a very simple case. Okay, capacity rocks, additional rocks. Okay. The maximum number of bags. Well, first thing I think is dp, and I'm gonna say dp based on the rocks. Like we have 1, 2, 4, 4, right? I say, okay, given additional rocks, but additional rocks, if I put what's the maximum we can get? Now what we want is give additional rocks, and then we go to the end. What's the number of maximum rocks that we can get? We can do another thing, right? We can do a difference and see how many rocks are needed to reach full capacity, right? So we find out, so it's 1, 1, 0, and then 1, that's for the first. So we just say, okay, given number of rocks, what will be the best distribution such that we reach as many zeros as possible? Oh, isn't that deterministic? We can go greedy. We always go the smallest first. Because, so these are the needed, right? And if we go the smallest first, then we have more chance. Because if you go a bigger one and you say you can reach more, then I can counter argue. So if you say we got this one, then I have more, I ignore the smaller one. Then I can say I can go the smaller one and then reach the same number. So it turns into this thing. We will sort it. So we get the capacity. Now we get the number that need to be added, and then we will sort it from small to large, and then just add one by one, add until we hit the additional rocks. This is 9. So we're gonna say diff, right, equals capacity minus rock for CR in zip, capacity and then rocks. And might as well just shortage it, right? And we can just say for D in this, and then we say S equal to 0. I can say for ID in enumerate this, what happened? S plus equal to D, and if S is larger than additional rocks, return I plus 1. Oh, it probably shall break and then return here. Because it could be the last one, right? If the last one is it might never break. Like S might never, like this is huge. S never break. So Yeah, we should always do it this way. Okay, let's try this. This one should be 3. Well, I like to do problem that's deterministic. I mean, all of them. Come on. All of them are deterministic. It's just a matter of how you can find a pattern in it, right? Like if it's DP, it is deterministic. You just need to figure out what is the state and then go through all the states. That's basically it. Oh, I was talking like this, but didn't realize I got it wrong. Ha! All right. Why? Because we hit zeros. Because we hit zeros, we just skip the zeros. If D, oh, we have to, oh my god. All right, we have to have a count, S and C. And we're not going to enumerate because we have to handle this D thing, right? If D, C plus equal 1, right? If this, and then we can just return C. What the hell? That's interesting. Well, for this one, there's no 0, right? And then we do it first, C plus equal 1, that's the first one. And it's not. And then C plus 1, the second one. That's not. And the last one, if it's larger than a rock. If it's not, actually, I shouldn't add it right now. Right, so the first difference, I try this, if it's larger, I should add it here. Right, because if it's smaller, yeah, if we explode, then we don't count this. But oh, now both are not right. Yeah, that's the difference, right? And then if difference, we have difference, then we say S plus equal to, so this is what we need. And I say if it's larger than additional rocks, if it's smaller, then we say we can add the current, right? And then we go again, and we do this, right? We plus this, and if it's not, then we plus again, and then we do the last one, right? And then it's larger than, no, because it's equal to the first one. Then how is C? That's very interesting. Yeah, we go 1, 1, 1. Right? That's very interesting. Hold on. CSD. Let me just take a look. C is 0, S is 1, D is 1. True. Next one. C is C. Oh, additional rock is 2. Oh, what am I doing? What am I doing? We have to count all the zeros. My God. If D, we do this, Otherwise, we do this. It's like, can we make this look better? Both have this, but we have a break. We can say s plus e. We can do this. We can do s plus equal d. Okay, and then we say if this, then we break, and then we do this. Okay. Well, it took a little bit longer than I wanted. Oh, we didn't test other cases. Well, I guess we don't have to test other cases. We got this one. We can use greedy. Go always fulfill the bag with the least number of rocks to add. Continue until we don't have any more rocks. Okay, I guess that's it for today. We saved one for tomorrow, so tomorrow could be a little bit less stressful. Okay, that'll be it. I'll see you guys tomorrow. Adios.